Hi, this video is going to help with the activity lab and lesson labs in 6.2 for course 1. So I just call them the labs. There's two, lesson and a activity lab. The first lab goes over mean absolute deviation. So mean, remember that's just the way to find the average. Absolute deviation. And the idea, or what this is I'm going to put this camera up just a little higher. What this does is it describes how the values in the data set differ from the mean. So it describes how the data set differ from the mean. It's another way to find dispersion, like how your data is spread out. So shows dispersion. So we are looking at those averages or those central tendencies, ways to find the middle, right? Or we're looking at dispersion. And so both labs are over different ways to find dispersion. We have the range, which we've already looked at. Now let's look at this mean absolute deviation. Now the formula, they call it the MAD, MAD, the mean absolute deviation. So look at the formula. It goes absolute value of x1 minus x bar plus, give me just a second, absolute value of x2 minus x bar plus dot 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 plus. It looks so ugly. X to the n. This is when you start to see crazy symbols in math, and they look ugly, but it's actually pretty easy to find. All divided by 2. That is our formula. So it's a fraction. Let's break it down and make it a lot easier than it looks. Okay, so we'll define a couple things. First of all, x to the 1, comma, or x to the 2, or x to the 3, or any number are just the data values in your set. So those represent data values. X bar is a lazy way of writing the mean. And that one will come up a lot because when you're using graphing calculators and stuff on anywhere where you see the mean, they use that symbol instead of actually writing the word mean. X bar is the mean. And then N represents the number of data in your set. So if you have 25 numbers, then your N is 25. If you have 10 numbers, your N is 10. So those are the three things we're looking at. So this is telling us to take the numbers you're given in your data set, right? We still have numbers. We're going to subtract the mean, then take the absolute value. Then we're going to add it to the next data set minus the mean, absolute value. Why absolute value? Because we're talking distance. How far from the mean are you? We don't care which direction you go from the mean. Remember, mean's the middle. You could go both ways. We're looking at that distance, which is absolute value. And so we're going to see how far away by adding up all these different, how far away they are from the mean and averaging it. And that's why it's called the mean absolute deviation. We're finding the mean, the absolute mean, like how far away we are from the mean on every single number, and the deviation is just how far away. So let's do this. We're going to have, we're going to do this with a small data set. So here's my example. They like to do 2 sets of values on each example that you're going to do out of the book. And this isn't in Math Excel, so you actually have book problems that you're going to have to write out and then submit your paperwork to me in Canvas. So it'll remind you in Math Excel to do it, and your grade will go in Math Excel, but then you have to actually complete it and submit it in Canvas. Okay, so let's just look at this first set. What if I have 62, 81, 74, 88, and 78? So I actually looked up your first test score, and those were the first 5 test scores that I saw in in Math Excel. So let's look at how we do this the easiest way. I'm going to do a little chart here, and I'm going to write the X's, all those are just our numbers, our data, on one side. And then I'm going to find the numbers. We use a little I for that, representing the different numbers on the data. We just used a letter. And absolute value of this. Okay, so what I'm going to do is I'm going to write each number: 62, 81, 74, 88, 78. And I'm only going to do this with 5, and all of your data sets are smaller because they're just too big. So what I'm going to do is take each data and minus the mean. So I have to find the mean. So what is the mean? Well, let's add those up and see what the mean would be. So we'd have 62 plus 81 plus 74 plus 88 plus 78. So I got 383 divided by 5, because there were 1, 2, 3, 4, 5 numbers. So divide that by 5, and I get 76.6. So that's our mean, and I'm going to then subtract that off each one and take the absolute value. So that makes me go 62 minus 76.6. Get out my calculator. That's negative 14.6. What happens when you take the absolute value of a negative? It becomes positive. So all of our answers we get better be positive. So I got 14.6. Okay, the next one, I take our 81 and I minus that 76.6, and I get 4.4, and it's positive already, but absolute value of positive stays positive. So 74 minus 76.6 is going to give me a negative 2.6, which again, take the absolute value. You're going to get a positive 2.6. Take our 88 and minus it from the 76.6, and we'd get 11.4 after the absolute value. Last but not least, 78 minus 76.6 happens to be 1.4. Again, take the absolute value. So all of our answers here are positive. So all I did is I took each number and subtracted off the absolute value and subtracted off the mean and found the absolute value. So when I subtract that mean, this is how far away each number is from the mean. So like this number's really far, that one number's pretty far, and these ones are all pretty small. Now I'm almost done. I have now found all in our backup here. I found all of these numbers, right? So now I have to add them up and divide them by, I put 2 up here. It should be n. I wonder where I put 2 for. Should be the number of them. There's 5 of them, not 2. So we're going to add up all of these to find our mean absolute deviation. So mean absolute deviation. So I'm going to go 14.6 plus 4.4 plus 2.6 plus 11.4 plus 1.4 is going to give me 34.4, and I have to divide that by the number of them that there were, which is 5. So divide that by 5, and I get 6.88. My mean absolute deviation is 6.88, which is actually pretty small. So that's about how far you are away from the mean. That's the average distance you are from the mean. So that's kind of how you find the MAD, or the mean absolute deviation. It can be tedious, so you could use your calculators or Excel to kind of help you with the subtraction, or however you want to do that. So that is all that you have to know about the mean deviation. Some of them are going to be bigger than others. What does that mean? It means your data is further away from the mean. It's more spread out. It's different. It's dispersed more. Okay? So that's our mean absolute deviation. The next one is actually a very similar deviation. In calculations, they're similar. This one is standard deviation. But this one we see a lot more in the real world. So standard deviation is the measure of dispersion on how the data set differs from the mean as well. So it's similar. It's still how the data differ from the mean. The other one is an average of it, and this one is a little different than just an average of it, but still the same kind of dispersion, similar similar thing that it's showing you. Here is the formula for standard deviation. Now this is, we're doing the absolute standard deviation, not the sample standard deviation. There's two symbols. This symbol just means standard deviation. And we would have absolute value of the, it doesn't quite look like the E that it should. Let me make it look a little better. There we go. X minus X bar, or means divided by N. Okay, there's our formula. Again, it looks really ugly at absolute value, a weird looking E. You got the symbol over here, the Greek symbol, and the X bar. So let's label each of these. First of all, this just means the standard deviation. Okay, and then the next symbol here that we see is kind of a weird E. It just means sum. It means add up those things. So we could have used that symbol in the last one, but they didn't, and then they used it in this one. X's are just your data values, so data values. And they don't use the ones on them, but same idea, data values. And then the X bar is still your mean. An absolute value you should know. Okay, so this is kind of the idea. Oh, and N is still the number of data that we have. Okay, so to figure this one out does take a little bit more than what the last one took. So let me give you an example of some numbers. So 54, 85, 93, and the standard deviation actually could tell us a ton more stuff about how spread out our data is, and we can actually like narrow it down and use it a lot more, but we don't have to learn all of those yet, so you'll learn them here pretty quick in the next level of math. But we'll start with just being able to calculate it today. So the first category, I just want to have the X's, the numbers. Here's all the X's. So we would have 54, 85, 93, 84, 89, 53, and 60. The next category, I want to calculate this part here, which is just X minus X bar. And that's going to be in my next row. And you could do this a little bit different than the way I am, but this is kind of the standard way to do it. The next one, I'm going to take those numbers and I'm going to square them. And that'd be my next row. And then the rest I'll figure out from there, and I'll show you what I mean. Okay, so those are kind of my categories to kind of help me do the math. So this is tedious. You don't want 50 numbers. You'd be doing this forever. So if you have a lot of numbers, you're going to do it in Excel or on a calculator. So let's find the X, the mean, first, because obviously I have to subtract the mean off, so I have to know what it is. So I'm going to add up all the numbers, and I am going to divide. So I'm going to add them all up, and I'm going to get 518. There are 1, 2, 3, 4, 5, 6, 7 of them. So I'll divide that by 7 to get a mean of 74. So there's our mean. So then I take each number, 54, and I minus 74. I did not give myself very much room, and that's going to give me negative 20. And then this next category is telling you to take what you got here and square it. It's an ugly way to say it, right? You see, you have the parenthesis and everything. So negative 20 times negative 20, or negative 20 squared, is positive 400. Okay, so then we do our next number. And I'm going to get a new pencil with a sharper lead and write smaller. I would have 85 minus 74, which is going to give me 11. 11 squared is 121. Okay, then I'm going to go 93 minus my 74, which is going to give me 19. And I'm going to square 19 and get 361. Better all be positive, right? Anything squared is positive. Or you just put it in your calculator wrong. So 84, I found it, minus 74. I couldn't quite get the right answer as the calculator, and I could not find my error earlier, but I found it now. 84 minus 74 is going to give me 10. 10 squared is 100. Okay, then 89 minus 74 is 15. 15 squared is 225. 53 minus 74 is negative 121. Again, square it. It's going to become positive 441. See, this takes a lot of time, and that's okay. 60 minus 74 is going to equal negative 14. 14 squared is 196. Whew, got them all. So what did I do? I found the mean, subtracted the mean off, kind of like I did in the last problem, but this time I squared them. Squared them all. Okay, now the next thing is to sum them, add them up. So the sum is just going to be adding up all of these numbers here, which is going to be, let's see, 400 plus 121 plus 361 plus 100 plus 225 plus 441 plus 196. So I just put them in my graphing calculator. Any kind of calculator is fine. Equals 1844. 1,844. And what do we divide it by again up here in the formula? N, the number of numbers that you had. So then I'm going to take this 1844 and I'm going to divide it by 7. Okay, I'm going to get 263.43 blah blah blah. Now I have to take the square root and that will give me my final answer. So on here it's over here, so I'm going to hit second hand to get the orange square root symbol to come up, and then I'm going to tell it to do it square root of the last answer, and I get 16.23. So the absolute or standard deviation is 16.23. Ta-da! Standard deviation. Done. This one is huge. It's going to be like we can take a bell curve and we can subtract and add this on the mean, and we can find out what's the interval range of different values. So this one is a lot more meaning necessarily than the mean absolute deviation. Both important though. Let me show you real quick how to do this same standard deviation on the in Excel, because everyone has Excel. First, just enter your numbers. So I have 54, 85, 93, 84, 89, 53, and 60. Okay, those are our numbers, and then again we push this function, and I'm going to put in standard deviation. Here's where it gets a little tricky. So it shows all sorts of standard deviations, and it tells you the definition here. This one estimates the standard deviation on a sample of your data entries. This is a sample deviation. We don't want a sample. Sample takes some of them and finds a deviation. We want the actual. So I keep looking. This one calculates based on entire population of database entries. So we want this one. Okay? And our database entries are these. Oops, I went too far. Okay, so, oops, that's why I was like, it's on 23. Oh well, it'll still do it. Okay. I must have done something. Oh, you know what? I think I clicked the wrong one. So let's try it again. Standard deviation. Standard deviation. It's hard when they give you so many different things. It's almost easier on the graphing. So this one's a sample. Which one was it? I think it was point P. Calculate standard deviation based on the entire population. Yes. Ignores logical. Okay. So just this one, I think, or this one. Let's try this one. So standard deviation dot P. And we wanted of these numbers here. Go over and highlight them. Hit enter. 16.23. Yay! That's the right answer. So again, that's how you can do standard deviation on Excel. You could also use it as like to help you add and subtract the mean off each one. And you could do each one separately, but you can actually find the standard deviation on there. Next, you can stop the video now if you don't have the graphing calculator. If you happen to have the graphing calculator, any of the TIs, then I will show you how to do this on the TI. Okay, so I'm gonna, there we go. Then you can see it. I'm shading it. Okay, so what we do first is it's all in the stat section. So I'm gonna click stat and I'm gonna get this and you're gonna wanna edit. That's the first thing. So you basically hit stat and enter. And what you want to do is list one, L1, you want to put in your numbers. You can see I already did that because I wanted to remember how to do this. It doesn't really matter if there's numbers in L2. We really only care about what's in L1. So you enter your numbers by clicking each one, and I can't quite get this to shade or hold it and shade it very good. Maybe I'll try something bigger. Ta-da. Okay, if anyone looks in my office right now, they'll be like, why is she holding a book above her head? Okay, so I put in all those numbers and I just hit enter on each number. Then so I hit stat, enter to get to that list. I'm going to hit stat again and I'm going to use my arrow key to go over to calculate, and I'm going to use the one variable stats. We only have one variable, L1, and we want the statistics of it. So I'm going to hit enter, and then I have to hit enter again. It automatically uses list one. Therefore, if you do not put your data in list one, you won't get the right answer. But you can see the standard deviation, it looks like a O, kind of like how we wrote it, is 16.23. So there's our standard deviation. Here's your mean. Here's all the numbers added up because there's our symbol for add. Here's them all up, added up and squared. Here is the sample standard deviation. So it takes a sample of ours. We like the other one. And you could go down and it gives you the minimum, the lowest number. It gives you your quartiles for box and whisker plots. And it gives you your median, MED, median, and your maximum. So this is, again, I hit stat. I went over to calculate, I hit enter on the first one, and I have to hit enter again to get it to actually come up, and then I can arrow back and forth. Once you click something, you can't arrow, so that kind of messes you up a little. All right, so hopefully you found this video helpful, and I look forward to holding my head, a book above my head again in my next video.